Welcome to The Explainer. Today, we're talking about a huge shift in the world of AI and computer vision. It's a story about a quiet revolution and how a king was dethroned.
So, not too long ago, this really bold claim started making the rounds online. It was basically signaling the end of an era. The message? The tech that had absolutely dominated real-time object detection for a decade had finally met its match.
So you have to be asking, how does a 10-year reign just end? To really get the scale of this upset, first, we've got to meet the king, and then we need to understand the fundamental change in technology that made its fall even possible.
All right, so let's start back in 2015 with the undisputed champ of real-time object detection, a family of models simply known as YOLO.
The genius behind YOLO was just its raw simplicity and speed. See, instead of these really complex multi-step processes, YOLO treated finding objects in an image as one single direct problem. It's kind of like this. It would look at a picture just one time and immediately say, hey, that's a car right there, and that's a person over there. It was a complete game changer.
And for a solid decade, the story of object detection was pretty much the story of YOLO's evolution. I mean, from its revolutionary start in 2015, it just kept getting better and better, version after version, faster, more accurate. It became the go-to, the default choice for literally millions of real-world apps.
But, even the most powerful technologies have what you might call architectural debt. These are design choices you make way at the beginning that eventually become your biggest limitations. And YOLO's debt, well, it was starting to come due.
Think about it like this. At its heart, YOLO is a CNN, a convolutional neural network. It works by looking at an image in little pieces, locally. Now, this makes it super fast, but it has a hard time understanding the big picture, the global context of the whole scene. It's great at seeing the trees, but it can totally miss the forest.
Okay, so let's really break this down. Over on the left, that's the YOLO way. It depends on these preset best guesses for object shapes, those are the anchor boxes, and then it has to do this kind of messy cleanup step to get rid of duplicate detections. But look to the right. That's a totally new approach, one that sees the entire picture at once and just predicts objects, clean and direct with no extra baggage. So into this world comes a new challenger. A startup called RoboFlow quietly released a model built on this completely new way of thinking. Its name, RF-DETR.
So RF-DETR's first secret weapon is that it's not a CNN at all. It's built on something called a vision transformer. Now this architecture, it doesn't just see pixels, it actually understands the relationships between them. It sees the whole scene in context, which lets it understand, not just detect.
And its second secret weapon is a technique called Neural Architecture Search, or NAS for short. So instead of being painstakingly designed by a human, RF-DETR uses AI to find the absolute best, most efficient version of itself for any specific job you give it. This makes it incredibly adaptable.
So here's the crucial point, right? RF-DETR just throws out the entire old playbook. It uses a massive pre-trained transformer, it gets rid of those clunky anchor boxes, and that messy cleanup step, it sees the whole image at once, and it uses AI to optimize itself. It's a completely different philosophy from the ground up.
Okay, but look, a new philosophy sounds great on paper, right? Performance is what really matters. So how does this new approach actually do in a head-to-head fight? Let's get to the data.
This is the number that changed everything. On the industry standard COCO dataset, RF-DETR became the very first real-time detector to ever break a 60 average precision score. That's basically its accuracy grade. A barrier that had stood for years was just gone.
And what's really interesting when you look at the full picture here is this. At the medium size, yeah, RF-DETR is right there, neck and neck with the best and fastest models. But when you let it scale up to its 2XL version, it just blows right past the competition in accuracy, hitting that absolutely record-breaking 60.1 AP.
But here's the thing. Being king of the lab isn't really enough anymore. The COCO dataset, it hasn't actually been updated since 2017. So to really measure how these models perform in the wild, RoboFlow introduced a brand new, way more difficult benchmark called RF-100VL. It's made of 100 really diverse datasets, everything from aerial photos to industrial inspection.
And this is where RF-DETR's big advantage really shines through. On this incredibly diverse real-world benchmark, it just consistently outperforms its rivals. This shows it's not just about being good at one test, it's about being able to adapt to the messy, unpredictable data you find in the real world.
So, okay, we've got a new champion.
But what does this massive shift from CNNs to transformers, what does it actually mean for you, for the real world? Why should you care?
Look, this isn't just some academic debate. For self-driving cars, this means safer roads, period. In robotics, it means way fewer mistakes on an assembly line. In medicine, it could mean more accurate diagnosis. In retail, better inventory tracking. This jump in performance unlocks totally new capabilities across some really critical industries.
So the takeaway here is pretty simple. A new kind of architecture has won the day. For anyone out there building with computer vision, whether you're a developer, a researcher, or a business leader, the ceiling for what's possible, well, it just got raised. A lot. So this really isn't just the end of one story, the story of YOLO's incredible long reign. It's actually the beginning of countless new ones, all made possible by a more powerful, more intelligent way of seeing the world. And that leaves us with one last, pretty inspiring question. Now that detection is this good, what are you going to build?